Okay, my name is Richard Stepp. I'm a standard plans engineer, central office up here in Tallahassee, where it's cold. And I held the primary responsibility for updating the following indexes: guardrail, concrete barrier, opaque visual barrier, and then some of the crash cushion details. And so some of them are just smaller changes, some of them are complete redevelopment. And so I'll go ahead and walk you through them right now. So the first index is guardrail, where we've added, basically updated our trailing anchorage from what we had been using for the past couple of decades, and then there's also updated downstream placement policy. And so the first thing to start off with is sheet 9, basically no more type 2. And so I think we had that probably for the last 2 decades. Anytime you were trying to put something on the trailing end of guardrail, you'd call out the type 2, and everybody kind of knew what that meant. But going forward, we now have a new kind that we're just no longer going to use that terminology for it. So basically, the soil plate anchorage system has been removed. Some rectangular washers have been removed. And then as far as additional things that have been added, this is the new trailing anchorage. And so we have a new strut system. We got 2 struts total, one on each side. That takes the place of that soil plate. We also have that post 2, the new short timber breakaway post, and then another tube foundation to help secure that a little bit better for MASH. And so these changes basically follow the latest design for MASH following discussions we had with Midwest Roadside Safety Facility. And then so on sheet 10, just to kind of support that, we added the detail for the ground struts. We deepened the steel tube post foundations, again, for our discussion with the research facility. And so to kind of tip off the contractors that there is a change because they've been building these things so long, they might not even look at the drawings anymore. We went ahead and changed the pay items to kind of let them know something's different. So now all the type 2 have been removed, as you can see, 25 and 28. And then if you look at the BOE, we've added in the pay item basically 20 and 29. So there is a change there, and in the BOE it lets you know when it's effective. So that's helpful. So pay item change on trailing anchorages. And then one other concept in talking with the research facility was that, and looking at their reports, is that we have a new policy for basically placing the trailing anchorage. Used to extend basically 1 post spacing downstream of the hazard. Now it goes 4 post spacings. And so they actually had done a lot of crash testing research on it and modeling. And it turns out that in order to develop this ribbon strength, you need to extend downstream of the hazard so that your vehicle gets captured upon impact going right to left here. I don't know if you guys can see the bottom of the screen. I heard that was an issue. But so basically, you know, in order to ensure you capture the vehicle, it doesn't just penetrate through and go to the hazard. You need to extend that downstream. And so this shows up in Part C of our new standard plans instructions. We explained the new policy. And then also, if you use the new length of need Excel sheet, it's going to show you that extension in the drawing automatically, so you know it's there. And if you actually use its stationing capabilities and you input your hazard in the right location, it'll automatically extend that downstream for you. So it's handled in multiple places to let you know. And that's all we have for guardrail. So now we'll move on to concrete barrier. And so we've got a new barrier mounted sign support option that's got dual supports. We have space constraints. We have a new call out for variable section width, the pay item for that, and we'll show you how that works. And then we have a new wall shielding barrier and some taper rates for concrete barrier. And so showing you sheet 8 now, this is a new sheet. We had a similar concept to this in years past, and we never really dropped the concept, but it wasn't drawn this way in the standard, and we had questions about it, so we went ahead and just redrew it and added another sheet to show you what happens when you basically add dual supports on top of the barrier and don't increase the width of the barrier at the gutter line. So the barrier basically stays 2 feet wide the whole way. You have no type of shoulder reduction. And so this would be used where you have a limited space, and if the designer wants to handle it this way, this would be a project-specific design. So we went ahead and added that option in. And I think in the future, the structures office may actually provide some support with helping to design the project-specific designs for these dual uprights. So you can stay tuned for that. So then moving on, there's this concept called variable section width that we didn't have in prior years. But now what's happening is we're attempting to capture our costs more accurately. And so when you have a simple barrier section that's like 38-inch height symmetrical medium barrier, that's very consistent, so you can capture linear foot costs very accurately for that. And then short grade separated, tall grade separated, they're all pretty consistent. But the thing that was throwing off costs and then future estimates was that we do have these more complex segments, we call them variable section width segments, that are all very project specific. And so in order to not kind of disturb these nice estimates here, we went ahead and came up with a new pay item called variable section width. And the DOE, it explains what they apply to. I'll just go ahead and show you some drawings on those because it's easier to see when we show you drawings. And so basically that's what you need to know is a pay item for variable section width. And for double face, you would use the median barrier version. And then for single face, you use the shoulder concrete barrier version. So it's a variable section width. And again, it tells you in the DOE what it's used for. And so to make it a little more evident to designers where the limits of that pay item are, we went ahead and put in the standard plans drawings what the limits would be. So I'll just show you some examples of that. So here would be our sign support. This would be the larger sign support that's mounted atop the barrier. You can see the barrier gets much thicker, gets much taller. It's not, wouldn't be the consistent linear foot cost with the 38-inch medium barrier over here. And so for that, we use a different pay item. So we went ahead and put this in the standard plan drawing so you can see the begin variable section station width and the end of it. And then similarly for this is the new dual upright. The same concept applies because this section is much different than the standard section. And so this one, it's not quite as easy to grasp the concept because the gutter line stays the same 2 feet wide. However, we still call it variable section width because the top of the barrier does get wider and it does get taller. It's basically non-standard. And in case there's any confusion, we just went ahead and called out in the drawings where the variable section width stationing is. And so another example is the split barriers that go around the sign support pedestal. All of this together is just considered one linear foot pay item cost. And I use this as an example to explain for simplicity, the linear foot measurement of this would just go along the center line. Even if there's dual sections, it's just one pay item and it just runs along the center line. This is usually symmetrical and pretty linear, so it should be easy to handle that way. And again, we called out the start and stop points. One other example is for shielding a pier. And this one, again, you can see this is all just variable, not standard shape. This is all highly project specific depending on the width of your pier. And so you can see where we would call out the different type of pay item here for variable section width. And then last but not least, this is a new wall shielding barrier. So it's a little sneak preview. So there you can see the retaining wall is here. This would be a standard section, but then you have the variable section width called out where this is all very project specific in order to handle that overhead sign support. And so this is an example of a single face version that would be the shoulder barrier pay item version of that. And so now moving on, we got the wall shielding barrier. And so this is some new drawings and kind of a new concept that we've now standardized for us. But it's not really a new concept for the state of Florida. We're showing here past examples, and I want to point out these are non-standard because in the past, we really didn't have drawings showing this configuration of a flush mount, kind of a half section barrier. We didn't explain how to handle, the joint behind it or anything like that. But designers were still electing this as project-specific designs. They were electing to do this, and it does make sense in certain locations. And why you might want to consider it is for just basic overall crashworthiness of the system. Some of the MSE walls maybe, they're vertical faces in general, but they may be less than ideal if their smoothness, is not the best. So, the one at the bottom of the screen here looks like it has a pretty roughened surface with a lot of ridges. You'd expect that this would snag on a vehicle more so than some of the smoother walls, and then certainly the barrier itself. And so to add some crashworthiness, it is beneficial. And then another effect of that is to provide a little bit of protection for the MSE wall itself. And so what's happening is the MSE walls tend to be, a lot more costly than a simple barrier. And so it's almost like putting in a sacrificial layer of concrete between the vehicles and the wall itself. So that may help prevent some maintenance costs. If the MSE wall takes a hard hit, it may require a panel replacement, and that could get costly and more complex rather than just having to replace a simple barrier. And so you have some added benefit of helping to shield the MSE wall, whether it really needs it structurally or not. And so now getting into the usage decision. So we're leaving it as it has been in the past, where it really is kind of just a project-specific district-level decision. And we're kind of happy where we've been seeing it in the past, to not really give, really prescriptive guidance on it. It's been showing up per engineering judgment as the districts request it in areas where we would want to see it. And so now we're just kind of providing some support for it with our drawings. And so the space required for the simple case, which is what we're showing here, this is just basically the flush mount, the most simple version of this. It's 1 foot, 3.5 inches. And basically that accounts for the barrier section itself and then a 1/2 inch preformed joint filler behind it. And so that would be the added space you need on your project to add a little bit of shielding. Now, again, looking at past examples, which we now provide some drawings for in terms of how to handle it, we now have the tapering of the barrier, which kind of tapers away from that MSE wall at different rates. In this case, it's for an overhead sign support to go around it. And so you can see kind of on the approach end, this is a gradual taper rate. Roadside Design Guide provides guidance on this, and now we will too moving forward. And then on the trailing end, in order to save space, this is kind of a steeper taper rate, which makes sense because you're not quite as concerned with vehicles getting snagged on the trailing side. And so I'll show you some of those tapers coming up as well. And then here are the drawings again to support that. You can see we have the detail. And so basically this overhead sign support would be a project-specific design depending on the size you need. And then we provide drawings showing the minimum dimensions all around it in relation to the barrier, in relation to the retaining wall, and then how to handle the backfill and all those other things. And so we have drawings set up for that. And as I was talking about before, these are project-specific tapers, which I'll show you on upcoming slides, where on the approach side, traffic moving right to left, it's more shallow, and then on the trailing side, it's steeper. And that also saves you significant cost with backfill of concrete or flowable fill by making these as steep as possible. And then, so another item configuration we've seen out there is connecting the guardrail. So you may be using Guardrail as an effective approach treatment where you put an approach terminal here, or it could just be a convenient way to continue on with the barrier on the downstream end. And so we went ahead and gave some details for that. So you can see here we're connecting to Guardrail, and this particular scheme then requires a minimum of 5 foot, 3.5 inches, basically to attach the guardrail and allow enough setback distance for deflection and all of that. And so we went ahead and detailed that out. We explained how to terminate kind of the backfill wall with some extra reinforcing for contractors and things like that. And again, this overhead sign support for connecting the guardrail, I mean, this may or may not even be here, but we're showing you just an example of how it would fall into things with the dimensioning around it, should you have to use a project-specific sign support behind it. And so now another version of this, if you have very limited space and you're trying to mount an overhead sign support atop a barrier, this now has the sign support directly atop. And so you're not placing it behind the barrier anymore. And in this case, you're tapering out to the full width you need on the approach, and this would be the project-specific taper, and then tapering back on the trailing end. And the space needed for this is project-specific depending on the overall width required for that support. And so now moving into these tapers, this is a new concept for barrier in general that we're introducing. It's been in the roadside design guide for a while. We're basically using the same type of policy, but now we went ahead and included it in our standard plans instructions because it's a good policy for certain circumstances. So the median barrier is consistently 1 to 20. Nothing really has changed here. This is the way the standard plans drawings have always shown it. Typically, median barriers are limited access facilities where you have plenty of space. For simplicity, we keep everything symmetrical. And for the design, it works out nicely. You could have possible contraflow and things like that, so we're just keeping it simple. But then where you tend to have limited space, and this is a newer policy, is the shoulder barriers. Typically, urban areas, you really want to maximize the space you're using. And for that case, we actually have taper rates that correspond to design speeds. And so the taper rate is basically the lateral offset per unit length. And that the lateral offset is measured from, parallel to the roadway. So, for example, the 1 to 16, 55 miles per hour would be, for every 16 feet longitudinally, you go over 1 foot laterally. So that's how that works. And then on the trailing end, they're all simply 1 to 5. We're not quite as concerned with snagging on the trailing end, so that's more simple, and it saves you some space. And then, so here's the picture of how these relate. So that would be the approach end with the direction of traffic coming from right to left. And here are the values, and they, for this particular one, you'd be using the shoulder barrier values, so you can adjust it based on design speed. And that can be a project-specific design, saving some space. Trailing end would be downstream, assuming traffic's coming right to left, and that's typically 1 to 5. Okay, so we've wrapped up concrete barrier and move on to opaque visual barrier. So for this index, we redeveloped an index sheet for clarity. From start to finish, we've added some design improvements for durability and varying barrier heights as well. We handle that now. And there's a new SPI and FDM section to provide some background explanation on that. And so here is an example of the previous standard for opaque visual barrier. So you guys can see kind of what we're talking about. So it's basically preventing headlight glare. Very typically these are installed, very metropolitan areas, high population. I think these photos are from Palm Beach. District 4, they have like 12 to 14 lane I-95 down there. And so it makes sense the way the designers have chosen to use this. And so in the past, we didn't have any type of really prescriptive usage policy. And moving forward, we're going to stay with that. We have added some more guidance and to add some awareness that this option exists. But we do like to leave it a little bit open in terms of allowing the districts to use this at their discretion at that level. Because where we've seen this being used in the past, despite no clear guidance for it, is in the heavily populated areas, like I said, South Florida, Jacksonville, Tampa, the really large highways. And the whole idea is if you have lots and lots of lanes of traffic and, vehicles trying to change lanes and make, maneuvers among lots of other vehicles, it helps if they're not looking at, 6 rows of headlights coming at them. It's one less distraction, results in safer driving. And so, these really urban areas, they are pretty cost effective. And so we've added this to the FDM just to kind of raise awareness that this option exists and provide a little bit of guidance. It remains a project-specific district-level decision. Basically consider it for limited access facilities with glare issues, high traffic volumes, separation between opposing traffic lanes, 26 feet or less. So that's, the 2 shoulder widths plus the 2 foot barrier. And then one limitation that we did add is that we don't want to see this being installed on overhangs, drop-offs like on bridge railings. So anytime there could be somebody in harm's way on the backside beneath it, like over a waterway, over a roadway, We simply don't want it to be installed because opaque visual barrier is a yielding design when it gets impacted, and it could fall. And so now we're basically saying that you have to have 4 feet of shoulder to either side of the opaque visual barrier. And so now that kind of limits it, so now there's no drop off. In addition to that, with the yielding design, when it's impacted, there could possibly be some debris, and the 4 feet just gives some room for the larger piece of material to fall to the shoulder without impacting traffic. Kind of the energy can dissipate a little bit. So it's just a little bit of a buffer that helps with safety. And so here are our new drawings. So the notes were written for clarity. We've added note headings to help people quickly find the information they're looking for. And now we're handling the new single slope barrier shape. We show specific drawings for that. Because the new single slope barrier is a little bit taller, the overall panel has actually gotten a little bit shorter, which is good for durability. And the overall height is 60 inches. And that's also true for the old F shape. And so we still support the old F shape. There's a lot of that existing in the field. If you're doing a new project and you have old barrier in place and you want to add some glare screen to it, you can go ahead and install it to the F shape, and we have details that cover that. One other improvement we made is the web is now 6-inch spacing. In the past, it was almost 2 feet. So the whole idea is to prevent, to kind of lessen the size of any impact debris should there be a severe impact. And then the other design improvement is joint spacing. Basically, we're requiring that the panels are at least 20 feet long. There's only one installation issue we've ever really seen in the past in one particular district where there was a maintenance issue because if these things got bumped by vehicles, they might start leaning. And I think it was discovered that the cause was that these panels were very short. And so when a dowel spacing is 3 feet, you'd only engage 1 or 2 dowels per panel. And so to fix that, we now have a minimum panel length that engages plenty of dowels and also adds some weight to it. And so any of the districts that had longer panels, there was never really an issue. So they had been performing nicely in the past when designed that way. So now sheet 2, we've handled some different configurations, maintaining the 60-inch opaque visual barrier height. We show a case where we have the barrier that's raising up for a large overhead sign support to 56 inches, and we basically show the termination of the opaque visual barrier panels. And so that's handled now, and the designer, roadway designer, doesn't really have to think about that due to the next concept. So we have a concept now, which is explained, the notes on sheet 1, and then the SPI, and even the specifications is called a leave out. So when you're putting in opaque visual barrier, you can just detail it as one continuous line, even if it's a mile long. If you have any interruptions, pretty much for overhead sign supports or light supports that are barrier mounted, or brief pauses in the barrier, you don't have to stop and start your length measurement. A leave out up to 15 feet is permitted with one continuous pad and measurement, and so that kind of helps out the designers keep things simple. And so this would be a large example of a leave out. We have a large overhead sign support, but you could have a lot smaller ones as well. And then one other thing we cover is when you have variable barrier heights, we just handle this for the contractor so the roadway designer doesn't have to think about it as much. If the barrier is raising up taller to shield a pier or something like that, the opaque visual barrier just continues right over it with the same height, and we show the details of how the panel itself gets shorter. And we also have SPI that's been redeveloped, so it covers crashworthiness design limitations. One thing I just wanted to read out for you guys are these design limitations for crashworthiness, so roadway designers don't get the wrong idea about it. But basically, we say opaque visual barrier is only intended for use as a visual screen. It's designed to withstand wind loading, light debris, minor contact from vehicles, errant vehicles. It's not intended to resist or shield against errant vehicle impact loads. So it's basically designed to yield if it gets hit by a serious vehicle strike, and then let the barrier itself, the concrete barrier, do its job. And so don't really install opaque visual barrier thinking you're going to be shielding a pier with it, because that's not how it works. It's designed to yield. It's just designed for a visual screen. So we also explain some general placement practices for split sections, which side to put it on. call out locations, and then some pay item information for opaque visual barrier. And then with that, we're finished with the OVB. So moving on to our crash cushion details. This is our last index I'm going to talk about. So we've redeveloped some index sheets in the SPI for clarity on the crash cushion, and we've redeveloped a summary of permanent crash cushion table. All these things hopefully increase understanding, make things a little more simple to use, and then we have a few new pay items for that, so I'll just walk you through those. And so one thing to mention is Index 544001, crash cushion details, is designed for permanent crash cushions. Temporary crash cushions is a different topic. The SPI for this even tells you where to look for temporary crash cushions. And so drawings and notes redeveloped. Length of need process has been simplified, which I'll explain. We've also simplified the table and the pay items. And so we got basically three concepts. First concept to talk about, it's kind of new, is it the crash cushion call out point right here. Basically this would be like your old station location. How you identify where your crash cushion is now the same as the length of need location. And so it creates a more simple process where the crash cushion just kind of extends downstream of the traffic. So it's the same as the length of need location. It's also the same as the begin-end guardrail station or the begin-end concrete station. So all these things now align for simplicity. And then now looking at the length of need design tool, this would be the drawing in the Excel sheet. I'll just reiterate the same concept. So you got your traffic coming right to left, your departure line, and that's kind of your length of need point. So your crash cushion station is right at the length of need point. It's right at the begin end of, you know, the concrete barrier, the guardrail, whatever you're connecting to. So that measurement is the same. They don't overlap for simplicity. And then also, you know, as I was saying, your connecting barrier. It's all the same point, all aligned. And then, so the second concept is now kind of what happens, I guess, downstream on the approach side of the point we were just talking about. And so that's called the length of end treatment. And so that's a kind of a simplified process we came up with. It's similar to guardrail approach terminal concept. And it basically includes all proprietary elements required per the APL drawings. And, you know, that can even include a manufacturer's transition is this thing. If you look at the APL drawings, they could require additional guardrail, and they'll show where you're going to connect to the standard guardrail in the APL drawings. That's mostly for the contractor to be concerned with, but regardless of what's required on the APL drawing, the designer can just assume this length of end treatment includes everything. And so what the designer needs to know is the default length for this in order to accommodate the contractor's choice of all different crash cushion types is 27 feet, 6 inches. So if you use that length, it will then accommodate the contractor to use anything that's on the current APL. And we even have in development some CAD tools with the DNC manager. Basically next month will be released where if you select the crash cushion, it'll automatically have a cell that's 27 feet, 6 inches long, and you can just basically click it, attach it to the end of the barrier you're connecting to, and then that, you know, you can use that to determine whether or not you have enough space for it. And if you don't have enough space for it, we have some other alternative options you guys can do, which I'll explain in a minute. Okay, so the third concept, getting a little bit more detailed. This is the last one. Basically now we're on sheet 2 of that index. So here's all the similar things we just showed you, length of end treatment. Here we have this parallel segment, which you have to know is basically from a design perspective, it's always parallel to the road, and it's always 21 feet, 10.5 inches long. So we got 21 feet, 10.5 inches. And that's always going to be required. The contractor may switch up the configuration. We have notes in the standard plans to explain to them when they need to use this configuration, when they don't. From a design perspective, you always need to have that link there that's parallel to the roadway. And one place that could come into play is where you have connection to dual bridges. You're trying to minimize your length of your guardrail with the crossover configuration. And so you got this parallel link. And that parallel link right there happens to be exactly 21 foot, 10.5 inches. that's the default in the Excel sheet. So that's a nice benefit of using the Excel sheet. It's just ready to go, and the note explains where it came from. And so you can see how all these concepts align. So that's a parallel segment, 21 feet, 0.9 inch, 21.9 feet. And then, so to read it one more time, we got the reminders of this whole layout. So we have our 21-foot 10.5 that's required. Then you have your begin end guardrail station, crash cushion station, length of need point at the end of that. And one other thing I'm going to point out is that this is the begin end guardrail station measurement. And then everything to the right side of it is just considered standard guardrail as a pay item. All this is included. The specification will explain that. And then the last thing is the length of end treatment is this portion here. So you got all the different portions, everything now aligned nicely. So this is a good resource to look at when doing your design. Now we have the SPI, we've redeveloped it. These topics are now explained, in my opinion, pretty clearly. So this would be the first place to look if you're new to crash cushion design, and it should handle all your situations. So it explains the location call out, which we've just gone through, the length of need process, which basically directs you to, if you're using guardrail, see the guardrail length of need tool. If you're using concrete barrier, see the concrete barrier length of need tool. Test level selection based on design speed, system width, length of end treatment, the default value, as we said, is 27 foot, 6 inches. And now constrained conditions, if you don't have that space, constrained conditions, which we won't get too deep into today, but we have some clear explanations in the SPI of how to handle if you don't have all that space needed for a crash cushion. There's multiple ways to reduce that space. And then you put it in the table for the contractor to see that they have a length restriction. Temporary crash cushions, just where to look for more information. And then we have a little portion for alternative crash cushion uses. If you're not connecting to barrier ends, you're just trying to shield it from hazard, we explain how to handle that. And so here are our new pay items. So we used to just have one simple pay item. It wasn't really covering the needs or communicating as clearly as we wanted to the contractor. So now we went ahead and improved that. So that old 75 is gone. And now we basically got two pay items, 544-2 for TL2, that aligns nicely for 45 miles per hour and less. 544-3 for TL3, that's over 45 miles per hour. And then the one other choice you have to make is whether or not it's a narrow or wide system. So in the SPI Part D, it explains for connecting the barriers, 24 inches or less, you're basically using narrow. That's standard is narrow. So the concrete barrier is 2 feet wide, guardrail is less. So that's narrow. And then wide would be something kind of extra large, basically. So then you go ahead and pick the -2. So that's the new pay item concept. And last but not least, we have a kind of a simplified table from what used to be there. And so I'll just step you through briefly the things on the table. So location, it's defined in SPI Part A, as we had mentioned, and right here. System width is defined in SPI Part B. It's basically what happens with this now. I guess Candy was clever over there and the CAD group, and realized that once you select your pay item, you're kind of by default selecting the test level and whether it's narrow or wide. And so once you do that, that's already taken care of. So then it will show up automatically in the pay item description. So if you use your DNC manager, you know, crash cushion width and test level is going to show up in the pay item description, so you don't have to input that. And so same thing, crash test level is going to automatically show up for you. And then so barrier width, it's defined in SPI Part D. If you're connecting, for example, concrete medium barrier, you go ahead and call that out, gutter line to gutter line, 24-inch barrier width. So that would be where that goes. And then last but not least, length restriction. Like I said, we have some good explanation to explain what happens when your default crash cushion length of 27 foot 6 inches just simply doesn't fit for project constraints. We have a couple of different methods where you can bring that number down. And then what happens is you're going to want to choose a number that allows the contractor to pick at least a couple crash cushions off the APL, but they may be shorter than 27 foot 6 inches. You input that value as a length restriction, and then that takes care of that for you. And so with that, I think Durwood's handling questions real time on there.